So here's my concept map. I'll begin by giving a little reminder of what I've spoke of in the MRP meeting. And then I'll be zooming into particular areas on my map and kind of discussing my thought process and how I developed my concept map. So first, the color. There is significance to the color regions on my map. The mellow yellow edges here basically are designated areas for these topics are just as important as all the other specific expectations, just perhaps not as rich as, say, the hot topics in the middle. And I've purposely fanned them out in that spectrum. So the hot topics, which are super rich, which we'll be spending more time on and developing more skills. And then the mellow yellow topics, more like building blocks that are more of like the foundations that build into these middle topics. So, and I think it's important also to mention that the building blocks in the mellow yellow region, they can kind of work in both directions. So they can serve as building blocks that lead up to the more enriched topics, or the enriched topics can kind of serve as a way to build the need to develop those building blocks. So they can kind of go in either direction. Okay, so my legend up here at the top, I have color coordinated the process expectations that I wanted to highlight. So I have green, yellow, blue, red, orange, black, and purple. I just wanted to mention that the purple here looks a little bit different from when I colored it on the specific expectations. For example, over here, the purple, this one's purple and this is black. So very small distinction. It's kind of hard to tell. Okay. And then also the specific expectations that I felt really incorporated all of the process expectations, and it didn't really make much sense to highlight one or the other because they were all interwoven in such a way that they were all of equal importance. So I decided to denote those specific expectations with a diamond. This fancy E that I have here is what I've designated as my exploration lessons. Okay. Now, I also thought that it was important to mention that although you may look at some specific expectations and think, well, there's process expectations that are on there's process expectations that are here that yes, it makes sense, but why aren't other process expectations included? So my thought process in that is that I really feel like some lesson plan or some lessons really lend themselves quite well to the development of certain process expectations better than others. So even though there are some process expectations that are involved throughout the lesson, that there's specific ones that I'll be highlighting in that lesson, and that's what I've denoted as the colors in each specific expectation. So my thought behind that is that because these certain lessons lend themselves better than others, I want to really consciously and deliberately focus on one or two at most process expectations in one lesson, because I feel like it will help develop a stronger foundational skill level mathematically in my students, so that they can develop those process expectations on such a deeper, stronger level that it will really overall give them a greater value when tackling the bigger problems where they are incorporating all of them. Okay, so I will go and highlight some of my thought process behind why I put certain colors in certain locations. So for one, here, let's zoom in here. So expectation 1.6, this is for the strand characteristics of functions. So here, determine through investigation the relationship between the domain and range of a function and the domain and range of the inverse relation. So I've put the process expectation for connecting here. In this exploration lesson, I really think that it's so important for my students to develop the understanding and the connection between a function and its inverse. And the fact that when you find the inverse of a function, that the domain and range basically swap. So sometimes it's easier to find the domain than it is to find the range. And if you find the inverse and you know the domain, then really you know the domain and range of both the inverse function as well as the original function. So for them to make that connection and develop that understanding, I think is important here, and that's why I've highlighted the connecting process expectation here. Furthermore, now on some of them where I put 2, I'll explain my thought process here. So for here, I have for expectation 1.9, sketch graphs of this function by applying one or more transformations to the graph. So basically various different types of functions with parameters in place. So selecting tools, the process expectation for selecting tools and computational strategies. So are we going to be graphing these functions on using pencil and paper? Are we using graphing calculator or graphing technology on the internet, etc.? So choosing those strategies that we'll be using for our exploration and investigation of these functions. And then the connections. So the connections piece is really important here, because what I really want my students to understand is the connection between the relationships between the parameters and the function. So the most important take-home message that I want to get across with this lesson is the idea that when we take functions to model real-life situations, that we're really, the parameters basically allow us to do that in a more accurate way. So, for instance, when we take a real-life problem and model it using a function, choosing those parameters in a specific way we choose those parameters in a specific way to better model the situation more accurately. And those parameters are really the strength in our strategy for modeling the problem. So making that connection between the importance of the real-world problem and the importance of the parameters at play in modeling the real-world problem, I think that is so important in stressing with this lesson. Okay, so moving on here to exponential functions. So I will highlight some of the specific expectations I've got here. Now, for how about 2.1? So distinguish exponential functions from linear and quadratic functions by making comparisons in a variety of ways. So basically, I've chosen the reasoning and proving process expectation here because, yes, they're developing the skill to differentiate between these different types of functions, exponential, quadratic, linear function. But it's so important here that I'm stressing that they can reason through that critical thought process, as well as being able to prove why they've said this is a exponential function and this is why. So being able to reason through that thought process and prove and verify their thinking as well. Okay, so now moving on to discrete functions, I have let's take this one because I've got 2 process expectations here as well. So on 1.4, represent a sequence algebraically using a recursive formula, function notation, or formula for the nth term. So here, the black, which is the process expectation for representing. So in the representing process expectation, it's so important that they're able to take a sequence and represent it using a formula. and being able to make that connection and comparing the sequence with the formula. But then reflection is just as important. So when they develop a formula, can they reflect and verify that that formula makes sense? So I would say that both these process expectations are of equal importance in this lesson. Moving on to trigonometric functions. So here, I will choose another one where I have two. So here I have pose problems involving right triangles and oblique triangles in three-dimensional settings, and solve these and other such problems using primary trigonometric ratios, the cosine law, and sine law. So here basically we're taking real-life problems, modeling them using trigonometry, and in order to solve them. So I have the blue, which is problem solving, and then red, which is reflecting. The reason why I chose both of them, I feel like they're both equally important, because the problem solving piece is the strength of the lesson, yes, and that's what we'll be highlighting in the process expectation, but it is just as important to reflect on the final answer, and does the final answer make sense with the real world problem. So, and then lastly, I will highlight one of my diamond expectations. So for instance, here under exponential functions 3.3, solve problems using given graphs or equations of exponential functions arising from a variety of real-world applications. So this type of lesson, it really lends itself really well to the authentic lesson type, say, for example, that Dan Mayer would produce. And this is so rich, and it's denoted by a diamond because it really does incorporate all of the process expectations. So when we are investigating a particular real life problem, first they have to select their tools they're going to use, whether it be which direction they're going to take, what mathematical tools they're going to pull out of their toolbox. And then they need to reason through what tools they're going to be using. They're applying their problem-solving strategies here. They're also reflecting on their strategies that they're choosing. They're reflecting on the different approaches to take. And then when they find their answer, they'll be reflecting on whether their answer makes sense with the real-life problem. The process expectation for connecting and representing are also just as important and interwoven throughout here, because they're making connections between the mathematical models as well as with real life. They're connecting their problem-solving strategies with the answers that they'll be producing, representing the problem and how they model it, and also representing the answers, and then the communication piece is really interwoven throughout as well. They're communicating by collaboratively speaking with their peers and communicating on a mathematical level. They have to communicate that they understand the problem at hand and the tools that they'll be choosing, and then communicating their final answer, and then proving if their answer makes sense. So it's so rich and involves that literally it involves every single process expectation and they're all kind of on an equal playing field, that it doesn't really make sense to highlight one or the other. It makes sense to highlight the process expectations on the other lessons as a means for developing those skills, but at the same time, these diamond lessons, they just develop them on such an equal level and such a great level of importance. So I think that kind of sums it up for my concept map. I'll also be providing you with some pictures that you can zoom in and take a closer look. Okay, thank you. Bye-bye.